This video explores why depression, autism, and gluten sensitivity might be on the rise. I'm actually going to talk about a few other conditions as well, including ADHD, obesity, diabetes, and Alzheimer's. I'll come back and talk about how I think all of these conditions are linked together in a moment. Understanding the discoveries that I'm putting together and going to present to you here was fundamental. It was a game changer for me in my own understanding of depression and ultimately in the experiments that I ran that allowed me to get better from depression. This video is an explainer video. It's more about the why and the what's going on. And what it will do is it will serve as a foundation for a series of other videos that I then show you how to apply some of the things that you're going to learn here in your own life. Before we begin, I want to talk a bit about the evidence in this video. Now, I am absolutely convinced that what I'm about to present is the major reason that these conditions are rising. However, at the date of posting this video, it doesn't rise to the level of scientific proof. Instead, it falls into the category of compelling anecdotal evidence. If you want to know what I mean by that, see my other video on understanding the scientific evidence used in this channel. More research is certainly needed, and indeed if I can get to that point in my life one day, I'd love to be able to drive some of that research. The evidence, though, I believe is truly compelling. So what I'm going to do is I'm going to make the case in this video, and I invite you to follow along step by step and see if you are compelled as well. In doing that, I'll cite some good quality studies and case study evidence that together create the pieces for this jigsaw. If you want to find the references to the studies that I've used, I'll list them on my website at annihilatedepression.com. I'm also going to do my absolute best to avoid jargon and just use simple terms wherever possible so that you can follow along. The beautiful thing about making the changes to improve your health based on the issues that I'm going to talk about here is it doesn't generally require a whole array of drugs. You can make lifestyle changes to try some of this stuff out. And in general, those lifestyle changes are pretty healthy, pretty positive ones to be making anyway. I've done it, and as I've said, the changes for me have been dramatic. Finally, before I get started, remember that just because I believe that this is one of the major causes in many, many cases, it does not mean it is the only cause for depression or indeed for these other conditions that I'm going to talk about. There is rarely one cause, only one cause for any condition. And even for me, it was more complex than that. I've talked in other videos about biological versus psychological causes, and some of the psychological causes were very important for me as well. So I'll return and talk about some of those in future videos. As ever, treating this condition or any of these other conditions is about trying things, it's about running experiments with help from a healthcare practitioner, and this video will form the basis for many of the ideas and experiments that I'm going to be talking about in the future for you to try. So what are the increases that we're seeing? And are they real increases, or is this something, is there another story behind these numbers? Well, let's start off by looking at depression, which is of course the primary focus of this channel. So here are some statistics on depression, and let's just have a quick look at these charts. So what we're seeing here is that from ages 12 to 13, between 2009 to 2017, so an 8-year period up until very recently, depression increased in the youngest age group here by about 46%, and then in ages 14 to 17 by 60%, and ages 18 to 21 by just over 45%. These are huge increases to be happening in such a short space of time. And indeed, 1 in 8 Americans, 1 in 8, ages 12 to 25, experienced a major depressive episode in 2017. Now, the statistics do vary quite a bit in different countries, and for the purposes of keeping this video relatively brief, I'm not going to cite all of the others, but there is a general problem across the Western world with increased rates of depression. If we look at all age groups since 2013, we see a 33% increase. And if you're wondering whether this is increased reporting or whether people are looking at the numbers differently or talking about this more, which, of course people are, which I think is great, the fact is that at the end of the day, the suicide rate in the United States has also gone up 33% since 1999. And there really isn't very much that can change in terms of the way that you report that. It's a fairly hard statistic. So Clearly these are real numbers, these are real figures, and it's not just a case of us talking about it more and increased incidence of reporting. I'm absolutely convinced that this is a real phenomenon that unfortunately is happening right now across our society and really has reached the level of an epidemic. For autism, this is another interesting one, and we're also seeing rises here. So if we look, the autism numbers were relatively stable up until about 1995, and then a little bit after that gradually started to rise. And so the statistics here are showing us that in 2004, 0.8% of the population was diagnosed somewhere on the autistic spectrum. And that rose to almost double that, coming close to double that by 2010, and those numbers have continued to increase. Now in percentage terms, in terms of percentage of the population, it's obviously quite a bit smaller, the number of people affected by autism than are affected by depression. And there is a fair bit of debate about how real all of these numbers are, and whether people are now more aware of it, and whether they're now reporting more of the edge cases, and that's driving up the numbers. And I think that it's possible that that's part of the story, but I also think that these are very, very large changes that are happening. And I also don't see any really good study evidence to back up the idea that this is just increased reporting. So yes, there may be an element of people talking about this more, but again, the chances are that there's no smoke without fire and something real is happening here. Finally, just to talk a little bit about gluten sensitivity. So, this is another really interesting one. 10 years or so ago, very, very few people knew what celiac disease was or talked about gluten sensitivities. And yet in the last few years, the term gluten-free can be found everywhere. It's on food labels, it's in health blogs, it's now a $4 billion a year food industry. It's really, really grown. And there's been a lot of skepticism about this in the scientific community. A lot of people saying, well, there are fad diets that catch on. Look at, some of the other diets that have appeared and then gone away again. But if you look at it, gluten-free has actually outlasted some of the other diets that have come and gone. Other fads like Atkins we're not really talking about anymore. Well, gluten-free and that movement started, even before that happened. There was always a classification of people who were sort of classically celiac or classically wheat intolerant or had allergies to wheat, but a whole class of people with supposed gluten sensitivity didn't show up with those particular markers. They didn't have those allergens. So what was going on here? And it was interesting because one of the researchers who was looking at this, and he was super skeptical, and until he discovered that in fact in these individuals they do have certain antibodies and blood markers that do increase when they eat gluten that shouldn't be there, and then decrease when stopped. And these markers were not present in control groups. So again, we're just starting to get to the point where there is this underlying trend that is probably quite real. Now, of course, diets do tend to spread through populations. There's a lot of chat going on about the keto diet at the moment, for example. And so there's an element of people jumping on the bandwagon with these things, as there always is. But the underlying truth of this condition is that it is rising, and we are finding evidence to back that up. So what could be the cause, and are these three conditions linked? It seems really odd to put all three of these conditions together into one video. They seem like they're very disparate, very different things. Well, I'm going to link them together in just a moment. So first of all, let's think a little bit about the cause. I've got a slide up here which obviously shows a genome, and I want to start off by stating the absolute obvious, which is that these increases cannot be caused by genetics. Think about the time scale. Genetics takes hundreds of years, thousands of years, tens of thousands of years to make a measurable change in a population. These are changes that are occurring over the last few years, over the last few decades. They're happening way, way too fast. So that means that we can rule out genetics as being the primary cause and the main contributor in these rises. So if they're not genetic, and they are real, they're not imagined, it's not just a fad, then the cause has got to be environmental. It's just simple logic. There has to be something in the environment which is causing these things to increase. And this is a really interesting, piece of logical reasoning, because you then go on to thinking about, well, what percentage of these conditions in total, even before they were increasing, was actually caused by an environmental factor and not caused by genetics. I'll come back to that. So, to cut a very long story short, There's a very curious finding in blood tests for patients with all of these conditions, which is not present in control groups, and it's called Lipopolysacharide. Now, I promise to keep this video relatively jargon-free, and I promise you this is one of only 2 or 3 pieces of jargon, but there's really no way of getting away from it, and I've got to tell you a little bit about this. So this is also known as endotoxin, and it's a really unwanted component. It should not be showing up in your blood stream at all. So what it is it's a major component in bacteria that live naturally in our gut. And it's a component in good and bad bacteria. And what it does is it makes the gut wall more permeable, and as that happens it then starts to leak into the bloodstream. There are these tight junctions on the endothelial wall of the gut where this molecule forces its way through. It shouldn't be found in the bloodstream at any significant level, and there's no other way for it to get into the bloodstream. It's not a byproduct of some other reaction that happens in our cells or anywhere else in the body. It's just a component of certain types of bacteria in the gut. Once it does get into the bloodstream, which it really should never ever do, it stimulates a massive immune response, and it raises all of the inflammation markers that you have in your body. All of the ways that your body reacts to fight an infection or to fight an invader, they all go off. And even worse than that, lipopolysaccharide, once it's managed to worm its way through the gut barrier, it's actually capable of then crossing the blood-brain barrier, which means that while it's very hard to track, we're seeing evidence that it can actually cause inflammation directly in the brain. This part that's supposed to be protected by this impermeable barrier can actually get in and cause damage directly there. So it's showing up in these conditions, and if we look, for example, at the conditions that I talked about, the first one being depression. The chart I've got on the screen here is showing antibodies which is your body's immune response to lipopolysaccharide appearing in the bloodstream with major depression. And as you can see in this particular study, the control group didn't have any lipopolysaccharide, and in major depression we have a score of 2.59. Now, if you're a scientist and you're thinking critically about this, you might be thinking, well, correlation doesn't prove causation. However, I will make the case for the fact that this is actually the cause later on. There is evidence that I think I can use to close the loop on this. So I'll come back to that. So it's a very important finding. This is a study that was done, I think, in 2008. I'll put a reference for it on my website, as I said. So in autism, we have a very similar issue. I'll just show you the study here. So this was a study that was done on low-grade endotoxemia. Remember that lipopolysaccharide is also known as endotoxin. And you can see on the right-hand side of the screen here the control group, and then groups with severe autism. And you can look at the fact that the levels of this particular substance has been raised in the bloodstream. And then we have another component which shouldn't leak out through the bacterial wall. LPS helps to kind of push this through the gut wall, and it's called propionic acid. And again, it's a byproduct of bacteria breaking down food in the intestine, and there shouldn't be very many of these bacteria doing this. It's particularly something that comes from certain species of Clostridia. And this has a really profound effect. So I'm just going to show you a couple of really quick videos on the effect that this has on rats. So if we look at this first video here, we have a healthy rat which is just going about its normal business and looks absolutely fine. And then in this second video, we've introduced, the researchers rather, introduced PPA into the bloodstream of the rat, and you can see that it immediately develops autistic tendencies. That just comes on straight away. And then obviously is reversible when that comes out of the bloodstream. So in fact, certainly in the case of LPS, it's used by researchers to induce inflammation because it then sets off these cascades of responses and allows them to test things. So what other conditions have elevated levels of lipopolysaccharide? Well, I mentioned autism, depression, and gluten sensitivity, but you also see it in obesity. And then you see it drive a whole variety of other inflammation markers in the bloodstream. So for example, it boosts the level of C-reactive protein, interleukin-6, tumor necrosis factor alpha. And these are all things that get released by our cells in response to this invader, as it were, coming into the bloodstream. And then you see raised levels of all of these in ADHD, Alzheimer's, asthma, cardiovascular disease, Crohn's disease, motor neuron disease or ALS, rheumatoid arthritis, and a whole range of other autoimmune conditions. You can literally go through the various different studies for these conditions and look at the levels for some of these proteins and for lipopolysaccharide, and you'll find that they're present. It's really interesting because the market for TNF-A inhibitors is about $20 billion a year. Now, I'm sure there are other reasons for that to appear, but if the primary reason for that coming into the bloodstream is stimulated by LPS, which is leaking through the gut, wouldn't it be better to start looking in some of these cases at our gut health and at the health of the lining of our gut? So this is not an exhaustive list. But it's interesting also, we know that genetics plays a role in some of these conditions. For example, particularly in Alzheimer's, if you have certain variants of a gene, you're much more likely to have or to develop Alzheimer's later in life. But actually, I think it's more a case that this is genetic susceptibility. And whatever genetic susceptibility you have determines which of these things is going to go wrong when LPS and some of these other molecules enter into your bloodstream. So which one of these genes is going to get switched on is more what happens. But if you don't have this happening in the first place, then you're not going to have the disease. And in fact, we'll come back and I'll talk about that specifically in relation to Alzheimer's a little bit later on. So when LPS crosses the blood-brain barrier, the starting point is things like depression, autism, and the end point is quite often dementia. And this next slide, we can have a quick look at how these things stack up and correlate. So there's this huge study in 2013 of 3.5 million individuals that were hospitalized between 1945 and 1996. So 91,000 odd patients hospitalized because of mood disorders. Being hospitalized because of an autoimmune disorder increased the risk of being hospitalized by a mood disorder by 45%. So these two things are correlating together. There's, what's the driving factor between autoimmune disorders and depression? Why are those two things linked? Depression is also more common with IBS. I have IBS myself, so I know that is a factor for me. Chronic fatigue syndrome, fibromyalgia, insulin resistance and obesity, these things are all correlated. You're twice as likely to develop dementia or mild cognitive impairment if you have depression. So there has to be an underlying thing that's driving all of these things, and it's LPS leaking into the gut because our gut walls aren't working very, very well. So if that's what's going wrong, then let's have a little look at the gut and try to understand a bit more about how this is getting generated and, in fact, what things should look like. Well, what should be happening is that we should be living in a symbiotic relationship with the bacteria in our gut. Now, this is relatively well known in science, but we are actually already symbiotes. We have these. I've got a picture of these birds on top of the elephant, the birds that feed on the parasites on the elephant's skin. There's a symbiotic relationship there in nature. Well, we're symbiotes ourselves. One of the most striking examples of that between us and in fact bacteria is in mitochondria. So mitochondria are energy centers in our cells. They drive aerobic respiration, and they were introduced around about the time that we started to develop higher brain functions. By weight in a human, they're about 10%, or they're thought to be about 10% of our body weight. And it's almost agreed, it's just about as close to agreed as you're going to get in the scientific community that they came originally from bacteria. Their DNA is a different shape from our DNA, and they just basically look as though they have actually come. Some bacteria at some point has ended up inside our cells, and it's developed this symbiotic relationship, which is now actually essential for our brains to function altogether. Well, what we don't know, and it's just starting to become apparent, is that a healthy gut is also symbiotic. It also, to this day, is absolutely critical. So our microbiome, the term for all of the bacteria in our gut, contains so many bacteria that they actually outnumber human cells by 10 to 1. Now, the bacteria are much smaller than human cells, so that's why the gut is only a certain size within the body. But they are absolutely vital. And when they're working well, they provide a huge range of functions, which range from immune signaling, directly generating neurotransmitters, regulating inflammation, and helping to maintain the integrity of the gut wall itself. So Lactobacillus Plantarum is found in fermented foods such as sauerkraut, which is one of the reasons why we want to get lots of live fermented foods into our diet, and it survives in the stomach really well for a long time. It helps to regulate immunity and it helps to control inflammation. It also helps to stave off rogue bacterial colonies. Bacteria compete for space in our gut, and they're very good at trying to make sure that they have enough space and to push out the ones that you don't want, or if you're overgrown with the wrong ones, they'll try and push out the good ones. This particular strain of Lactobacillus also helps to fortify the gut lining, which reduces the risk of all mental health disorders. It helps you to digest protein directly. It also helps you to absorb and maintain levels of omega-3, of vitamins and antioxidants. And it's been shown in mice, I appreciate that's not humans, but it has been shown in mice to help protect against multiple sclerosis. Lactobacillus Acidophilus is found in fermented dairy, including yogurt. It helps to curb the growth of bad bacteria. It helps to curb the growth of yeast. It helps to maintain cholesterol levels in the body. So imagine that cholesterol is actually in part regulated by the bacteria in our gut. And it manufactures lactase, which is the enzyme that helps to break down milk to digest it. Lactobacillus brevis, found in pickles and sauerkraut. It's also used in medicine to treat some types of infection. It helps to create BDNF, brain-derived neurotrophic factor, which grows new neurons in the brain, which helps us to form and stabilize memories as we relate to experiences in our world. Bifidobacterium Lactis, found in fermented milk, such as yogurt. It's shown in controlled trials to reduce digestive discomfort when taken by mouth. It's shown in controlled trials to boost immune response. And it knocks out foodborne pathogens such as salmonella. And Bifidobacterium Longum, one of 32 species in this genus, it's one of the first to colonize our bodies at birth. I'll come back and talk about that in a minute. It helps to prevent diarrhea, food allergies, it helps to improve lactose intolerance, it reduces anxiety. Along with L. acidophilus, it helps to maintain cholesterol levels, it helps to create BDNF, brain-derived neurotrophic factor, and it's been shown in studies to help suppress cancerous growths in the colon, possibly by slightly tweaking the pH. So these are very small examples of what should be a really rich, really diverse ecosystem that has built up over millennia that helps to keep us healthy and regulate our immune system and our brain function and a whole variety of other things. What has happened over the last few decades is that this is a microbiome that has been absolutely decimated. And I'll come on to how it's been decimated in a moment, but first of all, let's just have a look at the state of the problem. So this was a really interesting study on a tribe of Yanomami natives, and they were first seen by Westerners in 2009 after 11,000 years in isolation. And the parasitologist who was doing this said, to find this kind of isolation is like an archaeologist finding something with different layers of earth, or going into the iceberg and finding isolated organisms that will shed light on bacteria and microorganisms that we might have had in our bodies in the past, but don't have anymore. So it's like opening the door to our past. And what they found is that the Yanomami Indians had twice as many different species of bacteria in their guts as Americans. That is a huge difference. What an enormous change to have taken place. We also have very recent studies on the Iceman, 5,300 years old. And there was a study that focused on one of the microbes, which is found in our intestine. And it's usually found in about 30% or so of Western individuals, apparently. And there were 4 different distinct types of that bacteria to be found in the Iceman, and only one in almost all of the guts that were tested in comparison in the Western world. So again, it's just showing that the diversity of gut bacteria has gone down. And then there was also this really interesting study, the impact of diet in shaping gut microbiota. It was comparing children from Africa and from Europe. So if we take a quick look at this study here. So we have on the screen a couple of graphs, and if you just have a look at graph A and graph B here. So graph A shows the children taken from rural Africa, and this green marker here shows the proportion of the bacteria that are from the classification Bacterotides, And these, I'm oversimplifying, but these are generally the better bacteria to have in your gut. And then from B here, we see that actually there's a much, much smaller proportion, and that we have got an awful lot of Firmicutes bacteria which have grown instead. And these are bacteria that we, generally speaking, want less of. So this is a relatively recent study showing these differences between these different populations, and it is absolutely dramatic. We have decimated our microbiome. So how is it we've decimated it in a short space of time, and then why is it persisting in the environment? Why is it that it doesn't just sort of reset itself with each person? Well, the fact is that we inherit our microbiome at birth when we're born naturally. And this is really interesting. If we're born by caesarean section, we have twice the risk of autism, 5 times the risk of developing some sort of allergy, 80% increased risk of celiac disease, and a whole variety of other things. Well, what's the mechanism of action for that? We're not inheriting that microbiome at birth. So in addition to the fact that we inherit our microbiome each time we go through the generation, there are a lot of things in modern living that really attack and really upset the balance. They breed the wrong types of bacteria, which then produce the wrong substances, which then start to erode the gut wall, which then end up in the bloodstream, which then cause these problems. One of the biggest of these is sugar. It feeds, it's not about having no sugar, it's about the amount of sugar we have in the diet and the bacteria that feed on sugar. It really does increase, ultimately, lipopolysaccharide and intestinal permeability. Along with sugar, we have other types of sugar like fructose, and in particular high fructose corn syrup, which really upsets the metabolism, is fed on by all of the wrong bacteria in the gut, and causes a whole wide range of different problems. Antibiotics are also a really interesting one. So antibiotics are essential when they're essential. They save lives, and we need to have them for those purposes. But at the same time, what is the impact on our microbiome? If you think about it as this rich colony with many different strains of bacteria, there are lots of very sensitive bacteria, and antibiotics are relatively indiscriminate in terms of they only go for certain classes, but they may wipe out a whole set of different types of bacteria, including some of the ones that we want. Gluten, particularly some of the more recently grown strains of wheat in farming that have become just really intense and really changed the structure of that, is an irritant. It is one of those things that is a bit harder to digest, and I think probably what we can say is that it needs a really healthy microbiome in order to be able to cope with it, and it helps to perpetuate this cycle. Being born by cesarean, as I said, there are other aggressive agents in our daily lives like chlorine, or I really wonder about what the impact is of low-grade pesticides and herbicides. Again, it's not proven, but these are things that kill bugs. We have a very delicate ecosystem, and something is going wrong. So I think it's worth at least asking these questions. And so what happens is that we pass on this less diverse microbiome with each generation. So, we lead a very modern life, high in sugar, high in antibiotics. Some of the bacteria die off, we then pass that on, and so it goes. And so if you look even just over the last few decades, the 80s, the 2000s, through to today, there has been enough time for this to take place. There's been enough time for our microbiomes to become sick, and the timing actually fits. If you think about all of the things that are coming in that are attacking the microbiome, penicillin, the first antibiotic, was discovered in 1928. Didn't become more widely available until a little bit after that. And then our diet changed. The advice was given in the 70s to swap healthy fats for carbs, or for the wrong types of fat. And that has really helped to breed the wrong kinds of bacteria in our guts, and helped to start, I think, the obesity epidemic. It was that very bad dietary advice that was given. Modern farming methods have changed: wheat, pesticides, herbicides. There are lots more chemicals in the environment. And so over the last 50 years or so, we have assaulted the diversity, the species diversity of our microbiome, on, and we've passed it from generation to generation. So how do you improve your microbiome? Well, this will be the series, there'll be a number of videos that I'm going to go on and talk about specific things that you can do, but just to give you a really quick overview here. You start off by measuring it, and there are various different ways of doing that. I've done several of them, whether that's stool testing or blood antibody testing. So you can use that to create a baseline. I'll talk about all of those methods in other videos. You can make changes to your diet. There's a range of different diets. I've tried several different diets. Some of them have worked really well. Others have been absolutely disastrous. So I'll talk through all of those. Fermented foods, pre and probiotics are another thing. There's one particular probiotic that I've had great success with for depression, but the rub is that you can't take it orally. So I'll come and talk about how you do actually take that in another video. And then there's things like fecal microbiota transplant, which is something that I have also tried, and I will come back and talk about that process and what that's like in another video as well. So what effect can improving your microbiome have? I told you at the start, correlation and causation are not necessarily linked together. Well, let's try and close the loop here and see what happens if we do actually make some of these changes. So for obesity, for example, there's a couple of really interesting things here. There was a study that showed that thin mice were fed the gut bacteria from obese humans, and they were fed the same diet as the controls who were not fed those bacteria. So 2 mice, same diet, same amount of calories, same everything, except one of them has been given gut bacteria from humans that are obese. And the mice that were given those gut bacteria became obese. And then the opposite was done. They were given gut bacteria from humans who were not obese, and they quickly lost their obesity. So there is something here in terms of bacteria that grow and build and thrive on certain types of food that then change the whole ecosystem to kind of preserve it in this kind of feedback loop. And this was also inadvertently reproduced in one human subject undergoing FMT, where they had FMT from a relative in a fairly desperate situation, and they needed to have it. And their weight changed to be more like the weight of the relative. So there's a huge element here, and we can show that making changes to the microbiome actually changes obesity. Reducing gluten in sensitive individuals, studies are now starting to show that does in fact reduce and remove the blood markers, as well as patients just self-reporting that they're better. We can see that the blood markers come down and that the level of health improves, and that the antibodies that were circulating in the bloodstream are no longer circulating. There was also this really interesting study, which is very recent. I think it's just at the time of doing this video, a few months old, where autism symptoms were reduced by nearly 50% 2 years after a fecal transplant. So this was improvements in the gastrointestinal condition and in the autistic spectrum disorder symptoms. And those two things correlated very closely together in the study, and they persisted. They did this for a bit longer than some of the other FMT studies had done it for, and it stuck. It persisted 2 years after this study was stopped. And at the 2-year follow-up, where we started with 83% of participants being rated as severe on the autistic spectrum, 2 years later, only 17% were rated as severe, 39% were in the mild to moderate range, and 44% of participants were below the diagnostic cutoff for autism at all. Now, this is a small-scale study. I think there were only 18 patients, and also it lacked a placebo-controlled arm. So I think it's really important that we now look to do a much larger study, which is properly placebo-controlled, to really raise the level of evidence. It's a good initial study, but again, it's at that level where it's on the cusp between being sort of compelling anecdotal and good evidence, and actually more research is needed to really replicate those findings and properly do a control group. But absolutely fascinating to see that happen. I've actually discovered another way to deal with mild learning disabilities that's got nothing to do with the gut, so I'll come back to that in another video, but this is obviously a really, really key piece. And then there's the Bredesen protocol for Alzheimer's, and in researching this video I noticed that he's just come out with a book which wasn't there last time I was doing all of this research on the end of Alzheimer's, but this is a really fascinating piece of work. So this doctor has worked with 100 or so patients now. He just published a paper recently with 100 case studies, where he implemented a protocol to essentially reverse successfully Alzheimer's in all of these patients. Now this, I don't want to oversimplify this. There were quite a few elements to this protocol, and that he looked at quite a number of the other markers and things, but at the core of this was changes to improve the microbiome. And he looked at restoring health with a mildly ketogenic plant-rich diet with some mercury-free fish in it. So it's really interesting. That's kind of at the heart of everything that he did. So this was a personalized protocol. So again, it lacks a placebo-controlled arm. It's going to be hard to really sort of scale this up in a way where, you know, some of the parts of the protocol were quite non-linear, so it makes it a little bit difficult. But again, absolutely fascinating. It just shows that, you know, this is possible. And if I, you know, in looking at what he's done and all of the various different markers he's looked at, what I've realized is that I've actually built something fairly similar for depression. I mean, it's different because depression is a different condition, but my goodness, there's an awful lot of overlap between some of the things that he's done for Alzheimer's and some of the things that I've actually done off my own bat for depression. So again, I'll come back and talk about what my stack is in another video. And finally, just to finish where we began with depression and with my own story, I used to have huge problems with my gut. I used to go out for dinner and then I would be really, really unwell by the end of the day. I'd have to come back, I'd have to lie down. I remember lying on the sofa with bloating and just feeling really, really ill. It used to happen over and over again, and it got to the point where I didn't know if it was going to be okay. Sometimes I didn't want to eat dinner because I didn't know if it was going to completely ruin my evening or not. It would happen some of the days and it wouldn't happen other days. And it went on for years, and it actually really had a huge, huge impact on my social life. It was absolutely crippling. And over a period of time, I got to understand all of this stuff, and I looked at it from, you know, both in terms of intolerance testing and from a microbiome perspective and from a diet perspective, and all of these various different things, and teased it apart. And, you know, I tried several diets. I've tried specific carbohydrate diet, cortisol connection diet, keto diet. I've tried almost every probiotic available. I've done fecal microbiota transplant. And it's made an absolutely game-changing difference. In fact, some of those changes to diet have raised my energy levels, they've raised my mood, and as a single biological factor, as I said earlier in the video, it's probably the biggest single thing. It wasn't the only thing, but it's one of the biggest things. And I think I was lucky in a way that my gut symptoms were so bad that they originally piqued my interest in whether there's a link between the gut and depression. I do believe that it's quite possible to have gut problems that create really serious health problems without really having symptoms in the gut. These bacteria present in different ways. They don't all produce bloating and cramping and, you know, these really noticeable symptoms. There can just be an underlying dysfunction, dysbiosis happening there, which is producing at most mild symptoms, but actually leaking toxins into the bloodstream. But even, you know, with this really severe dysbiosis, it took me years to tease it all apart. And I remember at first I was confused because I thought that the depression might actually be causing the gut problems and not the other way around. And it seems that a lot of the medical establishment perhaps shared that confusion. But the more I experimented on it and the more research started to come out and the more I was able to untangle it. I would like to say a heartfelt thank you to Dr. David Perlmutter, the author of Brainmaker. It was the start of a really big turning point and inspiration for quite a few of the experiments. Reading that a few years ago was really one of the aha moments, and I can't recommend it highly enough. It really is a fabulous book that puts together the evidence and a lot of what I've been saying in this video in a really understandable guide. So anyway, I'm convinced that this was one of the biggest factors. Is it the only biological factor in my depression? The answer is I don't know, because while I am doing much, much better on the gut health front, there's still room for improvement, and I'm still doing some of the other things that I've needed to do for depression as a whole. So I hope you enjoyed this video and found it useful. Do let me know if you agree or disagree with what I've said in the comments section, or if you've had particularly good or bad experiences in the gut and in any way relate to this. If you enjoyed this video, please be sure to give it a thumbs up so that we can spread this content to more people. And if this is the first time that you're watching one of my videos and you're not yet a subscriber, please do hit that subscribe button so that you don't miss out on any more content. I've got lots of exciting content to come. Thanks for watching, and I'll see you on the next video.